Hello guys, another tutorial here. Well, I saw some people on the Discord are making shooters and think of recreating the feature I used to make for my day job of creating some sort of the threat indicator. It can be used for damage indicating system or even for the world compass that shows the direction to the objective. Also, as you can see, here we have our material and we will start from this point. I'm a very big fan of procedural content, so you can skip this part and just scroll the video to see the approach, how I achieve the movement of this particular widget, and you can go with the simple texture. But for those who want to receive this kind of material and to have more control over the material, like the depth, the color and so on, and make it different for different attractors, different instigators. So we can start from this point. And the first one we'll talk about is our arc mask. So first we need to create the whole radial mask, and for this we need to subtract from one radial gradient exponential node other one with the smaller radius. Then we need to withdraw some vertical pixels on our UV grid. For this we need to have the linear gradient masked on the G channel. So this particular what it does. And when we combine this mask with this mask, we'll receive our arc. Also, I'd like to admit that for my widget I use user interface as material domain and the blend mode set to be translucent, because if I go with the mask one, this transition on the edges would be discrete and the result actually looks ugly in my opinion. Next, we need to calculate our triangle. It's this operation. So if we take a look on our UV, you'll see that 0, point or black color is on our left top position and 1 and 1 on our right bottom position. To make triangle mask work, we need to create some sort of 3D vectors so we can manipulate dimensions of them. And we need some vertices. So this vertex 0.1 is for our bottom left corner, 1 and 1 for our right bottom corner, and 0.50 for our middle position on the top. So if we take a look at the mask here, you can see that we have triangle. So when we subtract from UV coordinates our vertices, we are offsetting the pixels on our UV grid. Then we need to compute the lines that should connect our points, our vertices. For this we are subtracting from each point position of other point, from first, second, from second, the third, and from the third, the first one. Then we need to use the cross product to tell which pixels should be inside our triangle. So if you take a look at, for instance, this operation, you'll see that the blue one here is those pixels that should be included inside our triangle, and the black one I withdraw from our mask. And when we combine all our masks, you'll see that we have some sorts of triangle. Next, we need to mask out the blue channel to receive the grayscale mask. Then we use sign, and this will return the very hot mask of our previous mask. So what it does, it actually returns -1 when the input, as you see, is less than 0, and 1 if it's greater, or 0 if it's equal. Also, we need to saturate it, so our negative values will be withdrawn, and we will go with only like from black to white color mask. Then we use the same gradient as we have here for our like small triangle on the top. So basically we are combining the linear gradient on our vertical position here with our triangle here. By multiplying those two masks, we'll receive some small triangle. Then we need to add our masks to receive the combination of those two masks, and here is our pointer. Also, I use multiply and opacity multiplier for like controlling how transparent or solid my pointer, my indicator should look. And that's it. That's the whole material. Take a look one more time. Now we can continue. Well, I've done it in my project, and I'll tell you the proper case, proper workflow, how to make it work in like with appropriate approach. So these cones symbolizes some sort of enemy's turrets. So let me show you how the blueprint of this works. Basically, I have simple cone and the sphere collision here. The collision preset is set to be custom. It's world dynamic. It ignores everything except the pawn. So when I step inside this area, it starts shooting at me. It's very basic logic, but it shows how the feature works. So on the component begin overlap of my sphere, I use cast to verify whether the overlapping actor is my character. Then, if it's so, I make timer which is looping every 3 seconds, and what it does, it's fire the event through my interface, I'll show it later, to actually show the indicator where the threat is coming from. And I'll also use like fire here just to trigger the every first entrance into this sphere collision, because without it, like this fire event will start only right after 3 seconds expanded. And when the overlap is ended, I clear the timer, so it should stop firing at me. Everything simple. So if you talk about the approach, how exactly the threat indicator should be shown, every enemy or every objective that you are interacting with should fire the message through the interface into your player controller or into your player character, where you have your widgets creation or widgets storage, and they should say that I'm interacting with you, so please draw our indicator. So my character and my player controller have the interface, which is called BPI player character. It's implemented inside my player controller because my player controller stands for my widget creation here. It can be in your player character. So basically what you need is to implement the interface like I have here and add it inside your or player controller or player character here. Once it's done, then you can create the functions inside your interface and use functions or events from different places, as I have it here in my turret actor. So one more time, I'm overlapping with the sphere collision. It fires the event, and this event sends the message, like create thread. So if you talk about the interface, I have two events. The one, create thread, with two inputs: direction from which the thread is coming up and lifetime of how long this indicator should exist. And the second one is remove thread, and the input is widget of my, actually this particular widget had incoming thread, so it should be your widget of this element. So we need to tell which particular widget we should remove from our HUD when the lifetime is 0. Also with my system you can make different lifetimes for different threads. You can use different colors, different shapes, and my system has the maximum amount of thread indicators that can be shown at once, and each new one actually withdraws the first one, so you will always have the valid new information about your thread. So once you've created those two events inside your interface, then you should implement the logic. So as you can see from my turret here, event fires create thread message to the interface. Because my interface is implemented in the player controller, I can use the abstract class of getPlayerController. If your is implemented inside the player character, you can go with getPlayerCharacter or getPlayerPawn. The lifetime here is set as 5 seconds, and I use actor location of the turret to tell where the thread is coming from. So now let's talk about the widget and then about the logic that actually handles creation and removing the widget. For widget, I use simple image here with the alignment of like centered one. I use size to content, so the size of my image says how it should be expanded over the window. Also, I have no binding here, I make some logic here. So on the event pre-construct, I create dynamic material instance of my material, this one that we created, or this one. Then I use set brush from material and use my material as a reference to actually overlay over the default image. Then on the event construct, I have two timers. The one is set to reveal the whole widget by default. Widget is set to be hidden, because before we receive any sort of threat or damage or whatever, the default position of the widget is like on the 12 o'clock. So to skip the flickering effect of this, we need to actually show our indicator like on the 0.1 second when the widget is constructed. So here I have the reveal event, and what it does, it actually sets the icon to be visible. Other one is the timer for the event. As you can see, I have thread lifetime here. It's actually the same attribute that we will use here. So it tells that right after 5 seconds our widget should not exist. So 5 seconds expands, our widget is destroyed. Make sure that thread direction or thread lifetime, those two variables here, are set to be exposed on spawn. So when we create our widget, here these two attributes are visible. So instance editable, expose on spawn for both of them. And what this event does, it's this one. It actually sends the message remove thread that we have implemented in our interface, and self as the reference to which widget should be deleted. And because we have this node getOwningPlayer, it will actually return the abstract class of our player controller, so this message will be delivered. And on the event tick, I have this math operation to actually rotate the widget over the screen. We use OwningPlayer, getViewTarget, getActorLocation to actually see like this will return the actor at which our player controller is looking at. So it's us. And thread direction here for the find lock at rotation node is for the example turret, this one. So when we use find look at rotation, we will have the vector, like the direction where our thread is coming from. And to make it work for our HUD, we break the struct, split, and use that axis for manipulations. Then we use getOwningPlayer camera manager, and this will return the actual active camera. In case you have some of them, it will return the one that is active. And we use getCameraRotation. Also, we break the structure on and use that axis and subtract from one other to receive the angle how our widget should be rotated. And we use set render transform angle for the whole widget, so whole widget will be rotating. That's the logic for the widget. Now player controller. Here, because we have implemented the interface player character, this one that handles those two events, we can actually call them like this, not the call, but implement. And on create thread, we create our widget, this one. Then I use it as the local reference, set it to be the variable, add it to the viewport, and then I have the array of the same element, this one. And that's what I need to actually work with the pool of threads. So the next thing is that I check whether I have the valid index of 0, the first one element here, and if the length of my list of threads is higher than 3. It means that if we have the fourth message, fourth thread, the first element or the older one will be withdrawn and the new one will come over it. So if it's true, we take the first element from our array and we remove it. Here we use the not message but the interface call, so we will actually fire this event here. And on the event remove thread, I check whether the widget that was sent is actually valid. So if it's so, we remove it from parent, and then we remove it from our array, so it won't exist there anymore. And that's how actually the whole system works. You can ask me questions. I have the Discord channel, that link is below the video. If something isn't working right, I can help you and I can make the sample project with like more straightforward logic, but I insist on using the interfaces so your project will work better. So I hope you like this video. Please subscribe if you also like my videos, leave your feedback, make your requests, and I see you soon.